Hello, my name is Alan Ivan, and welcome to the presentation of the second assessment of machine learning module. My student ID is 008511040, and I will walk you through the performance analysis on data augmentation in machine learning. The goal was to evaluate the performance of data augmentation, and I needed a data set. I focused on carton and plastic. Had these two classes and 100 images per class. I have provided noise, color, and mixed augmentation, a combination between those two. And I have trained and test using machine learning on the real data sets, various augmentation, and various hybrids as mixed between those two. I have used tools such as Python 3, Anaconda, OpenCV, scikit-learn, and TensorFlow. I've also created a command line menu where users can load, augment data, train, and test. The experiments consist of applying machine learning methodologies, more exactly k-nearest neighbors and convolutional neural networks. The train test ratio was 80% training and 20% testing. I have used 10 different data sets as they are illustrated in the diagram. I have used real images data set. Then I have created 3 augmentations, noise, color, and a mix between noise and color. And then, as you can observe in the middle layer, I have merged real images with the augmentation in a hybrid data sets. First, I have done this by providing a 50% plus 50% from each data set. And then I have created another added noise augmentation, added color augmentation, and added mix augmentation by providing 100% plus 100% images from real and augmented data sets. So I have 10 different data sets, various augmentations, and various hybrid data sets. The source folder contains a documentation folders, various folders for images, a README, which I suggest you read before you try the code, because you can get guidance on how to start, run, and apply machine learning. But it's also easy, as I have provided a menu. And we also have a set of Python files, which are menu.py, main.py, data.py, augment.py, and ml.py. Menu.py provides the menus as we print them. Main.py provides the logic according to the menu. So in respect of user input, it will run some processes, it will call some functions. Data consists of functions that are loading, saving, and displaying the data. Augmentation consists of functions that are applying noise, applying color, or mixed augmentation, a data generator function, and a main create augment data function with which we can create and augment any kind of data set. And the most important file, the machine learning file, ml.py, contains 2 functions that concatenate data in various percentages. These are used to create the hybrid data sets. A data preprocessing function that is creating the main data sets, real, noise, color, and mixed. It creates them in a sensible structure in preparation for machine learning. Then it creates the following 3 data sets. The acronyms means hybrid, H for hybrid, R for real, N for noise, color, and mixed. And AHRM and the subsequent, the acronyms stands for added, hybrid, real, and noise. So it creates 10 data sets, and then it returns them. It returns them in the runML, which is the main machine learning function, which calls then for each of the data it actually sends all the data and so calls each representative function in respect of user input. Each of the KNN, CNN functions are applying machine learning for each data set in the data. And for the KNN, we use a k-neighbors classifier with 3 neighbors. All the data, images, augmentation, and hybrids have a 64 by 64 resolution. It's an RGB, 3 colors. The convolutional neural networks, it's a bit more complex than the standard classification, in the sense that we reshape the images, we provided convolutional layers, which are three convolutional and 2 layers for max pooling on a 2 by 2 matrix. We train and feed the models, and we provide reports, we return the results. Let's go for a test. Yeah, I don't have a GPU. I don't need it now. Welcome. This is a research of the efficiency of augmentation. Blah, blah, blah. We start by loading the data. When we load the data, we get plotted a sample from the images from each of the class, so carton and plastic. We can observe the diverse nature of the data set, which is very good. Then we augment the data, and as we augment the data, we can observe, this is the mixed one that I'm highlighting now. This is the color augmentation. So if you watch this ball, which is the color augmented, and the first one, we can observe a tone. It doesn't have to be a lot. It's important in machine learning, and we will see this in the results. And somewhere here we got the noise as well. Let's see which one. This one must be the noise. So we created 3 more data sets. Each one is 200 images, 100 per class. If we display the data, we will observe all the data that we are about to use in machine learning. Image data, which is the real data set, 1, noise 2, color 3, mixed 4. So we got 4 data sets. When you go in machine learning, we get to choose one machine learning methodology, and then in pre-processing, 6 more data sets will get to be created, so a total of 10 will be used. KNN is very fast. So after pre-processing the data, we got 10 different data sets in which both the data in the target have the same value, 200, 200, and the last 3 data sets are double in size. Then we print the shape of the NumPy arrays. We can observe the ratio that we're about to test. And then we can observe the post-processing results, the train accuracy and the test accuracy for all the data sets. KNN has been run 10 times, and the data was collected for reports purposes. Now let's run the CNN. The convolutional neural networks in this case scenario runs only 1 epoch. It runs 1 epoch for each of the data sets, which are 10 in number. And for the results report, a total of 10 epochs have been run for each of the data sets. We got the results after at each step, but we also got like a whole report at the end of the last epoch, I guess. We got the train loss, the train accuracy, the test loss, and the test accuracy. That's pretty much it. Now, after training and testing using both k-nearest and convolutional neural networks with various tuning parameters such as changing the learning rate, we have maintained the categorical cross-entropy as the loss, and also we have maintained accuracy as the metrics. But what has been changed, attempted, was the batch size 1 to 8, 5, 2, 5, 6, and 5, 12, the epochs 5, 10, and 20, the learning rate, and the third convolutional layer has been added. Yep. And in neighbor classifier, 2, 3, and 4 neighbors have been tried. And this is has been concluded as the optimal settings for the machine learning. Now, these are the results that have been concluded. We can observe a substantial difference between KNN and CNN. Obviously, KNN seems to be better, slightly better when it comes to standard classification, at least with a small number of epochs in CNN, and with a small data set, I suppose. We can observe just a little bit of improvement in the case of CNN, with an exception when we double the data set and provide color augmentation. Not the same case with KNN, in which we can observe a significant improvement in case of augmented data, a more significant improvement when we add augmentation on top of real images, and the highest results for 50% plus 50% real and augmented data. From these results to conclude, especially that I see the highest accuracy on hybrid augmentation plus real, I would argue that it's very important to provide diversity and quite a lot of information in the image you provide to the machine learning. It doesn't necessarily implies a lot of images, maybe subject to what machine learning you use. But it's obviously important to provide diversity, not only the real data set, but also provide data sets that are augmented in some way, rotated images, added noise, color by some extent, or brightness, anything. As a further step for this research, more machine learning methodologies could be used and applied in the scenario, or the current ones, KNN and CNN, could be studied more in depth and try to first to determine why there is such a big difference between CNN and KNN. I think that would be the next step. Yes. We also got some merged results, in a sense that we got real, augmented, hybrid, and hybrid where the data set is double, like added hybrid. And same here, because it's just consolidated data, we can observe that hybrid 50% plus 50%, it's the best case scenario for the current research. I hope this was useful and interesting to see. This was all for this presentation. Thank you very much for listening.